Have you ever gazed up at the night sky and wondered about the life story of those distant twinkling stars? Each one is on an incredible journey born from cosmic dust, growing over billions of years and ultimately meeting a dramatic end. This life cycle known as stellar evolution is not only a captivating tale, but it also holds the key to understanding our own place in the universe. Well, brace yourself for a journey through time and space as we delve into the fascinating process of stellar evolution. Every star begins its life in the same way, as a nebula, a giant cloud of dust and gas. Within these nebulae, something extraordinary happens. Invisible forces start to pull the particles towards each other, a dance orchestrated by gravity itself. This gathering of particles is not a swift process. It takes hundreds of thousands of years. But eventually, these particles coalesce into a dense region known as a protostar. Now, the protostar is not yet a star. It's sort of like a star in its teenage years, still growing, still forming. As this protostar continues to accumulate mass, things start to heat up. The pressure and temperature at its core increase dramatically, reaching a point where hydrogen atoms begin to fuse together to form helium. This process, known as nuclear fusion, releases an enormous amount of energy, causing the protostar to shine brightly. And just like that, a star is born, ready to shine brilliantly for millions or even billions of years. After spending a considerable amount of time in the main sequence, a star enters its middle ages. During this stage, the star undergoes significant transformations. It's like a cosmic makeover. The star starts to expand, bloating into what we call a red giant, or, for the heavier stars, a supergiant. This expansion is due to the star burning helium in its core, a process that releases energy and causes the star to swell. But the changes don't stop there. Oh no. The star also begins a process known as shell burning. This is where the star starts to produce heavier elements in shells around the core. Imagine an onion with its multiple layers, each one producing a different element. This process results in the creation of elements as heavy as iron. This middle-age stage is a critical turning point in a star's life. It's like the midlife crisis of the cosmos, setting the stage for the final act of stellar evolution. As the star exhausts its fuel, it faces one of two possible fates. Like actors taking their final bow, stars too have their closing moments. Smaller stars, those up to about 8 times the size of our sun, embrace a rather peaceful finale. Their outer layers drift away, leaving behind a glowing core called a white dwarf. This cosmic relic, no larger than Earth, will cool and dim over billions of years, becoming a dark ember in the vastness of space. Our larger celestial performers, however, exit the stage with a bang. Stars at least 8 times the size of our sun culminate their lives in a spectacular supernova explosion. This cosmic detonation can outshine entire galaxies and, in its aftermath, leaves behind either a neutron star or a black hole. Neutron stars, incredibly dense and rapidly spinning, are the universe's ultimate spinners. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. But here's the beautiful part. These grand finales aren't just endings. They're beginnings too. The elements forged within a star and dispersed in its death throes are recycled back into the cosmos. These elements, from carbon to iron, from neon to nitrogen, seed the interstellar medium, paving the way for the formation of new stars and planets. In the grand cosmic drama, even a star's death gives rise to new beginnings. Stellar evolution, as we've seen, is a process of transformation and rebirth. It's a cosmic dance that begins in a nebula's dust and gas, where gravity pulls matter together to give birth to a star. Over billions of years, these stars burn brightly, fusing hydrogen into helium, releasing energy and light. Eventually, their fuel runs out, leading to their twilight years where they expand into red giants or shrink into white dwarfs. But even in death, stars give life. They explode in supernovae, scattering their enriched contents across the universe, seeding new stars, planets, and potentially, life. This continual cycle of stellar birth, life, death, and rebirth is the heartbeat of the cosmos. Understanding this process is crucial. It provides insights into the universe's history, its future, and our place within it. It reminds us that we are made of stardust, born from the ashes of stars. So, the next time you look up at the stars, remember, each one has a story to tell, a story of birth, life, death, and rebirth in the vast cosmic theater.